So today I'd like to talk to you about Innovatech's story of development of a silver-based seed treatment and foliar spray. But before I get into that, I'll just tell you a little bit about what makes Innovatech tick, and that's biofilms. Sorry, and which button do I press? The right one?
I should have told you that.
Okay.
Yeah,
That one
side
here?
forward, that side back, and then laser pointer is here.
Okay. So biofilms, basically bacteria exist in two states. You have the planktonic or free-floating bacteria, or you have biofilms, which are communities of bacteria. And one of the simplest examples of biofilms is the slippery coating on a rock in a stream. That's a biofilm. So scientists know a lot about the planktonic bacteria, and planktonic bacteria have been the basis, as a result, for the development of disinfectants, antibiotics, treatments, and the regulatory standards that guide them. Unfortunately, typically biofilms are the real problem. And so biofilms can be up to 1,000 times more resistant to treatments than the planktonic bacteria. And that's partly because they adhere to surfaces, they form communities, they form protective coatings. They have all these mechanisms to defend themselves against removal and against being killed by antibiotics. And we run into biofilm-related problems on a daily basis in the newspaper. You hear about things like contaminated foods, you hear about hospital superbugs and wounds that won't heal, and particularly related to my talk today, you hear about farmers having to destroy crops because they're infested with a disease that can't be treated, and so the only approach to prevent it from spreading further is to actually destroy the crop. And so Innovatech works in all of these areas to try and develop solutions, but for my talk today I'm going to focus on that last one and focus on agricultural applications for anti-biofilm treatments. And so I'm just going to sort of walk you through a story of our commercialization process, and I'll start with where Innovatech started, and that was looking at biofilms on plants. And initially we were looking at Pierce's disease, which is a disease of citrus crops, coffee, grapes, and so on. But what we found is when we were looking at Pierce's disease, we discovered there was actually little or no knowledge on biofilms in general in plant diseases. And so all of the blights, spots, molds, and so on that you run into on plants were actually being caused by biofilms, but the treatments that were being developed were for planktonic applications. And so where we were seeing failures in existing treatment regimes, is because they were focusing on the wrong thing. At the same time that this was happening, our research director was working with Dr. Burrell on silver for wound healing, nanocrystalline silver, and our research director thought maybe there's some plant applications for this. And so he began looking for a high oxidation state silver with a slow release profile, and he was looking at materials that were available in the literature, and also looking for what would be the most appropriate application. And originally, they were thinking about looking at a cut flower preservation model. And that turned out not to be a good business model, because if you think about buying your cut flowers, the florist wants to give you those little packets of preservative for free. So if you want to add something like silver to them, you're not going to make a lot of money. At the same time, though, Innovatech realized that the agricultural industry had a real problem regarding streptomycin seed treatments due to the fact that bacteria were developing resistance to streptomycin, and so there were bans coming into effect. And so here we saw a real need because there really weren't any other treatments available for bacterial blights, and although there was some copper treatments, they tend to be poorer antimicrobials, and so you end up having to treat them at levels where toxicity becomes an issue. And so we started screening silver compounds, and we basically used our company's core technology, which is the MBAC assay and the associated BEST assay. These assays allow you to grow high throughput biofilms, and basically the bacteria are in the same form that they would be existing in the natural environment, in the biofilm state. And so we actually use this core technology to screen all of the chemicals and stuff that we are developing, and I'm not going to go into the assay at all, but just so that you understand that we were using that core technology to screen the silver compounds that we were then going to look at for anti-biofilm activity against plant pathogens. And from that screening process, we came up with Agress, which is an oxysilver compound. It's a high valency slow-release silver. It's a unique species that has activity against both bacteria and fungi and plant pathogens, which is rare in antimicrobial treatments in agriculture. And we looked in terms of the application to focus as using it as a seed treatment and foliar spray in pulse crops was where we started. And so the next step was to look at field studies and greenhouse studies, and we found that in fact Agress was very active against the plant pathogens and could be a solution to the biofilm problems that were plaguing the pulse crops, that it has broad spectrum activity, and that it would be an appropriate replacement for streptomycin. At the same time, we found out that, our plant pathologist tells me this, that the amount of Agress that you need to treat an acre is about what would fit on your fingernail, so that makes it cost-effective and environmentally friendly. So that was good news. And so basically our plan for our path to market was what you would expect, that we would do some more R&D, we would do a submission for a pesticide registration with the EPA and the PMRA, and then we would look for a partner to go along the path to market. And while that path never changed, you'll see over the next slides that we had some twists and turns that we had to deal with. So first, after we'd done some more R&D, we filed our IP, and our initial patent was sort of an umbrella patent that covered the application of a number of silver species, including the oxysilvers, to plants and plant parts to treat biofilms. And we were looking at both uses and compatibility with other agents in that patent. And as we go along, we've been filing subsequent patents associated with specific applications, such as specific diseases like fire blight, as we see that we have activity there, or enhanced germination, so as we see other properties of the compounds. And so then we moved into regulatory, and Innovatec had no experience with regulatory, especially on the agricultural side. We'd had experience with FDA, but not with EPA. And so we looked for a regulatory consultant to help us out. And so we researched several, and we found one that told us that silver was well known to the EPA, and so Innovatec should be able to apply for waivers for large amounts of the application. And as we found that for our particular compound, that was not correct. And we'll talk about that more in a few slides. There was one positive outcome of that, though. Our application to the EPA attracted Syngenta's attention in 2008, and the subsequent relationship with Syngenta attracted the attention of investors to the tune of $3 million, and that made it so that Innovatec could stay in business, essentially. Throughout this time, we also developed relationships with growers and saw an expanding role for Agress, not only as a replacement for streptomycin, but also as an additive to other pesticides with synergistic effects. And so now we come to the first twist, in that I've alluded to earlier, and that was the regulatory. So the EPA came back saying that the data provided in the original application was not sufficient for them to tell whether Agress was safe or not. And in fact, that the chemistry data provided didn't give them enough information to decide what other studies they needed to see. And so after a number of communications with the EPA, first thing that happened was our consultant quit. It turned out that they were essentially used to dealing with generics, and so something where they could kind of tag on to previous applications. They didn't know what to do with the new active, so they quit. And so we withdrew our application to the EPA to reevaluate the chemistry, and that was about when I came on board as well. And Innovatec also found a new consulting company that had a lot of experience with applications involving silver. And so then we come to twist number 2, and that's in the R&D. And what happened was when we went in and we reevaluated the chemistry, we found that the manufacturing process that we've been using, which was based on the literature, actually was generating 2 compounds. It was the same cation, so the same active ingredient, but there was actually 2 anions present. And so what we did was we developed a new manufacturing method so that we could make both compounds pure. We went through a whole lot of testing to decide which compound was the better compound to go forward with, and that included testing at ACAMP, such as that lovely SEM there. And from there, we found that we've greatly increased our knowledge of oxysilver chemistry. We're going to have a better product with a better manufacturing process for our next submission, and that next submission is going to be a lot more complete. At the same time, the knowledge that we've developed, nobody has that knowledge, and so when we publish that, that's going to contribute significantly to the public knowledge of high valency silver as well. So that was sort of the positive outcomes of that. our third twist was our partner. And so what happened was Syngenta released Innovatec from our obligation to the right of first refusal. And basically, their reasoning was that they hadn't seen a proof of concept on a major field crop, which was true. We'd always told them it was for pulses. And also that they weren't seeing the duration of activity that they were looking for. We knew that they were undergoing internal restructuring and a change of focus towards the major field crops, so they weren't as interested in the pulse crops anymore. And at the same time, there was definitely some misunderstanding about Agress, how it should be applied, what it should be used for. And so we learned some things from that. But at the same time, Syngenta continues to show interest in Agress, and we anticipate working with them again in the future. But again, there was a positive outcome from this, and that was that our release from our obligation to Syngenta actually opened the door for other partnerships. And so we've had 5 different companies, chemical or seed coating companies, approach us since we had that release, and they have all expressed interest in Agress. So we're excited to see what will come out of that. And at the same time, we're taking the opportunity, since we've had to step back a bit and look at the chemistry and all that some more, we're taking the opportunity to expand the potential of Agress. So we're looking at applying it to horticultural crops and also to field crops based on the feedback from Syngenta and from other companies. So we're doing work now in small grain cereals, corn, rice, and various horticultural applications. And so just to finish off, I would say some of the things that maybe we've learned as we're going through. One of the things is not to rush the process, in the sense that when you're a small company, of course, like Ken mentioned, you want to get to revenue and you're looking for sort of the fastest route through, but sometimes it's important to do some extra work up front to make sure that you've got your bases covered. At the same time, it's really important to make sure you have good help. Especially as a small company, you can't do everything, and you're not expected to do everything, but it's important to have good collaborators and good consultants to help you along the way. And probably the most important thing is there's always going to be challenges no matter how much you have in place. And as they come along, the best thing that you can do is just to learn from them and use them as a way to get a better outcome in the end. So thank you, and here's my contact information.
Before I say any questions of Patricia, I'll say the short version of what she just talked about was that she saved our product by coming on board. So we're very happy about having her on our team now. Any questions of Patricia? In the back?
I've heard from several people over the years that it's unlikely that bacteria are going to build up an easy resistance to silver as compared to the organic antibiotics. Do you want to comment on that?
Yeah, so one thing that I would say is it is possible to develop resistance to silver. I've done it in the lab before, so it's not a never and impossible situation. But the advantage of silver is that there are multiple mechanisms of action that the silver has against bacteria, and so you have to overcome all of those in order to develop resistance. And so the probability is much lower because you kind of, like, you multiply each one together, right, to have the probability of developing resistance. But with any product, you need to make sure that you're using enough to actually kill the bacteria, not just inhibit it. The other thing is silver 1 species and metallic silver species individually are going to be more likely to be able to develop resistance, or I should say the bacteria are more likely to develop resistance to them. If you add things like, say, the nanocrystalline silver, high oxidation state silver, you're adding additional mechanisms, and so that makes it even harder to develop resistance.
Okay.
Have you applied to other areas besides crop silver technology?
We actually have a sort of a second generation family of silver compounds that we're looking into more medical applications for. Yeah.